Good morning, everyone. I'm delighted to welcome you today. Today, we will explore the fascinating topic of variants of SARS CoV-2. This presentation will cover the different types of variants, their characteristics, and what they mean for us. Let's dive in and learn more about how this virus is evolving. Thank you for being here. Today, I want to talk about the different classifications we use for viral variants. First, we have the variant of interest, or VOI. These are variants that show some signs of spreading or have mutations that might affect how the virus behaves, but we need more data to understand their impact fully. Next, there's the variant of concern, or VOC. These are more significant because they have demonstrated evidence of increased transmissibility, more severe disease, or reduced effectiveness of vaccines and treatments. Then, we have the variant of high consequence, or VOHC, which is a rare category. These variants would pose a major threat to public health, potentially undermining our current diagnostics, vaccines, and treatments. Lastly, there are the variants being monitored, or VBM. These are variants that health agencies keep an eye on to see if they develop into something more concerning over time. All these classifications help us understand and respond appropriately to the evolving virus. They guide our public health strategies and underscore the importance of continuous surveillance. So, as we move through this presentation, keep in mind how these categories fit into the bigger picture of managing viral threats effectively. Now, let's look at some of the key changes that can happen in the receptor binding domain of the virus. These changes can lead to a reduction in how well antibodies generated from previous infections or vaccinations can neutralize the virus. In other words, the immune response might be less effective against these variants. Additionally, these mutations can impact the efficacy of treatments and diagnostic tests, making them less reliable or less effective. We also often see a predicted increase in transmissibility or even disease severity with these changes, which can make controlling the spread more challenging. However, it's important to note that such variants usually have limited prevalence at first. That's why the CDC takes action by ramping up surveillance and conducting epidemiological investigations to monitor and understand these changes better. In the classification of variants of interest, or VOI, these factors are crucial because they help us stay ahead and adapt our public health strategies accordingly. Now, let's discuss some of the key concerns associated with these variants. First, there's an increase in transmissibility, meaning the virus spreads more easily from person to person. This can lead to quicker outbreaks and more cases overall. Additionally, these variants tend to cause more severe disease, which puts greater strain on healthcare systems and increases the risk of serious outcomes. Another critical point is that these variants show a significant reduction in neutralization by antibodies generated during previous infection or vaccination. In other words, the immune protection we have might be less effective against them. This can impact the overall effectiveness of our current vaccines and treatments. Speaking of treatments and diagnostics, there's also a reduction in their effectiveness, and in some cases, diagnostic detection may even fail. This makes it more challenging to identify and treat cases promptly. In response to these challenges, action has been taken. We've notified the WHO and CDC to coordinate our efforts, increased preventive measures such as masking and social distancing, and ramped up research to understand better how effective our vaccines and treatments remain against these variants. All of these points highlight the importance of staying vigilant and adaptive in our response to emerging variants, which are often classified as variants of concern, or VOCs, because of their potential impact on public health. Let's now look at some of the critical challenges we're facing with this variant. First, there's a demonstrated failure of existing diagnostic test targets, which means our usual testing methods may not be as reliable. This is concerning because it hampers our ability to quickly identify and isolate cases. At the same time, we're seeing a significant reduction in vaccine effectiveness, making it harder to protect populations through immunization alone. Therapeutic measures are also less effective, which complicates treatment strategies for those who do get sick. All of these factors contribute to more severe disease outcomes and an increase in hospitalizations, putting additional strain on healthcare systems. In response, action has been taken. We've notified the WHO and CDC, and we've announced new strategies to prevent or contain transmission. This includes updating our treatment protocols and vaccines to better address this new threat. This particular variant is classified as a variant of high consequence, or VOHC, which underscores just how serious this situation is. It reminds us of the importance of staying vigilant, adapting our approaches, and working together to mitigate the impact of this emerging threat. Data indicates a clear impact on available countermeasures, which is important to understand as we evaluate how our strategies are holding up. Some variants cause severe disease or increased transmission, but interestingly, they are no longer being detected in the population. This suggests that while these variants can be more concerning, our current surveillance and response efforts are effectively managing them. Previously, these variants were classified as VOI, VOC, or VOHC, meaning they were designated as variants of interest, concern, or high consequence. However, they are now circulating at low levels in the USA, which indicates that they haven't become dominant or widespread again. We are actively monitoring these variants through what we call variants being monitored, or VBM. This ongoing surveillance helps us stay ahead of potential threats and adjust our public health responses accordingly. Overall, this highlights the importance of vigilant monitoring and adapting our measures based on the evolving landscape of the virus. Let's take a closer look at the list of variants and their current statuses. Starting with the Alpha variant, which is classified as B117, and it's currently listed as VBM. Similarly, the Beta variant, classified as B1351, also falls under the VBM category. Moving on to the Gamma variant, identified as P1, it remains classified as VBM as well. The Delta variant, with the designation B16172, is still considered a VBM. Now, the most notable change is with the Omicron variant, which has the designation B11529 and its descendants. It has been classified as a VOC, or variant of concern, since November 26, 2021. This list highlights the evolving nature of the virus and how different variants are monitored and categorized based on their impact. Recognizing these classifications helps us understand the current landscape and the importance of surveillance in managing the pandemic. Let's take a closer look at some of the key variables we're working with: epsilon, eta, iota, kappa, zeta, and mu. These are collectively known as VBM. Now, what does VBM stand for, and why are these particular variables important? Well, VBM often refers to a set of parameters or factors that we analyze to understand underlying patterns or behaviors in our data. Each of these variables has its own significance. For example, epsilon might represent a small but impactful effect size, while eta could relate to a specific rate or coefficient. Iota, kappa, zeta, and mu each contribute their unique insights, helping us build a comprehensive picture. By focusing on these variables, we're aiming to identify the core elements that drive the phenomena we're studying. Recognizing their roles and interactions allows us to develop more accurate models and make better-informed decisions. This set of variables ties back to our overall theme of understanding complex systems through targeted analysis. It's about pinpointing the key factors that matter most, so we can focus our efforts where they'll have the greatest impact. Let's go over some key terms to better understand the viral variations. First, a mutation is simply a single change in the viral genome. It might seem small, but these changes can have significant effects on the virus's behavior. Next, we have the concept of a lineage. Think of it as a group of closely related viruses that share a common ancestor. All the lineages of SARS CoV-2 are responsible for causing COVID-19, which highlights how the virus evolves over time. Within those lineages, we also talk about sublineages. For example, BA275 is a sublineage of BA2. It's like a branch stemming from a larger branch, a direct descendant of its parent lineage, showing how the virus continues to evolve and diversify. Now, a variant is a virus genome that contains one or more mutations. Variants can be classified as VOI, VOC, VOHC, or VBM, depending on their characteristics and impact. These variants can sometimes be more transmissible or evade immunity, which is why they're important to monitor. Finally, we have recombinant viruses. This occurs when two different variants infect the same host, and during replication, their genomes combine to create a new, recombinant variant. This process can produce a virus that's different from both parent lineages and can happen if someone is infected with two variants at once. Understanding these terms helps us see how the virus is constantly changing and adapting, which is crucial in tracking and managing the pandemic effectively. Let's take a closer look at how these lineages are organized. Think of it like a family tree, where each branch represents an evolutionary descendant of a common ancestor. These lineages are connected, showing how the virus has evolved over time. Now, when we name these lineages, we use a system that combines an alphabetical prefix with a numerical suffix. This helps us keep track of the different branches and their relationships clearly. Specifically, the Pango lineage system is a standardized way to assign these names. It's widely used in the scientific community because it provides a clear, consistent method for nomming and tracking variants as they emerge and evolve. Understanding this hierarchical structure is key to following how the virus spreads and changes, which ties back to our overall goal of monitoring and controlling the pandemic. Now, let's take a closer look at this tool that helps us classify sequences based on their genetic relatedness. Essentially, it groups sequences into branches that reflect their evolutionary connections. These important branches, often called clades, are labeled to show they originate from a common ancestor. The nomming system is quite systematic. It starts with a 2-digit year indicating when the clade was assigned, followed by a letter that shows the order of assignment within that year. This way, we can easily trace back the timeline of how these groups were identified. This tool, called NextClade, is really valuable because it helps us understand the family tree of the virus or organism we're studying, connecting the dots between different sequences and their evolutionary history. It's a key part of tracking how the pathogen evolves over time and spreads across populations.